Hey, hi everyone. Let's look at bloom filters. So, what bloom filters are? So, I'll start off with an example. So, when we use uh, any pass like any username checks or anywhere on internet, we type a particular username and we quickly get saying, okay, this username is not available. If you look at it, it's pretty damn fast. Like it's we are not doing any calls or anything, but it comes up saying, okay, this username is not available. How is it saying it? So this is pretty fast due to it uses Bloom filter. Bloom filter is a probabilistic algorithm which says whether a certain element exists in set or not. So it cannot certainly say that element exists in the set, but it can certainly say that element is not existence in a given set. So let's see how it works. So this so into the workings of it. So this core idea behind the Bloom filters is we have some n probabilistic functions and we pass the input x through all the probability functions and we'll get like a binary like binary string from each each hash function. So from all these binary strings, we have a global filter which is called Bloom filter, and we will be setting the bits to one wherever we see ones in our uh, results of our hash function. So essentially, what we have right now is in our global filter, wherever there is a one, uh, like where there is a one, meaning it came from a hash function for a input x. So how it can say that the element x is not there in the set? So if you pass the element x again through the same hash functions, you will get the same set of binary strings. If you like, if from our input state, if the element exists, we set all possible uh, binary like bits to one from the hash map outputs. But if any of the hash map outputs is not present in the our global Bloom filter, we can certainly say that element is not existent in the uh, given database. If it is present, we can say that the element might be present and might not be present because the same like since hash functions are random, there might be overlap between two inputs x and y, giving similar patterns for the ones that we have. So let's go through this example. So here we have the letter geeks. So we have three hash functions, h1, h2, and h3, and passing this geeks to through all the hash functions, we'll get. That's for simplicity here. They have given 147, meaning the first bit, the fourth bit, and seventh bit are ones. Uh, Set them to ones. So this is our filter, and we are setting the first bit and the fourth bit and seventh bit as ones. So if we run through the geeks again, we'll get the same 147. So if we compare this 147 with our existing uh, global hash map, uh, global uh, Bloom filter, we'll certainly see that 1 is already present, 4 is already present, 7 is already present because we had already written this element to the set. So we can clearly say that this element might be present in the list. And if at all we didn't write geeks to this set, let's say we wrote something else, like let's say we wrote something else which gave us outputs of 1, 3, and 0. So 1 and 3 are ones. But when we pass geeks, we have 147. So the seventh bit won't be uh, in green, so which will tell us that geeks is not present if uh, because the 7th bit is not green. If it was present, 7th bit will be green because in the input pipeline it should have gotten the 7 and we should have turned that bit. Yeah, that's all about the Bloom filters. Thank you.